this video we're going to be explaining how to simplify factorials. As a simple example, we're going to go over 8 factorial. 8 factorial will be equal to 8 times 7 factorial as an example for right now. But this can also equal 8 times 7 times 6 factorial and so on. So if I expand this, the entire factors will be simply a continuation into I get to 1. Okay, now let's look at it in general. So let's say, for instance, n factorial, where n could be a number or it could also be an expression. Alright, so here you can see that this is n according to our example. The next number has to be 7. So n minus 1, n minus 2, n minus 3, and so on until you go to 2 times 1. Okay, on this video, now we have 2 examples where we can interpret our n factorial. In this situation, we can have n factorial as n plus 1. So the whole expression can be interpreted as n factorial. So if you remember the examples we did a few seconds ago, so the original factor will be identical to our factor. And then our second factor will be simply n plus 1, and then we have to take away 1 from it. And then we keep doing this, n plus 1 taken away 2, n plus 1 taken away 3, and so on. Now going over the bottom part, or our denominator, so we can expand n factorial the same way. So this will be n times n minus 1 times n minus 2, n minus 3, n minus 4, and so on. Now if we try to simplify this, let's go over here. This is equal to, so our first term will be n plus 1. Our second term will cancel out the ones, so I have an n, and then our third term will be n minus 1. Therefore this will be n minus 2, and so on. And now our denominator is n minus 1, n minus 2, n minus 3, and blah blah blah. There it goes. So now we can see that these factors will cancel out automatically, and now we can see that our pattern starts to repeat on our numerator, n minus 1, n minus 2, and so on. So we can see the same pattern in our denominator, therefore they will cancel each other out. So the answer for this particular problem will be n plus 1. Okay, now here we have another example. We're going to continue with the same process. So in this particular problem, our n factorial, it's simply this expression, 2n minus 1. That will be our n, and then factorial. So this is equal to, again, the same factor originally as it is. And then our second factor will be 2n minus 1 minus 1. And then our third factor is 2n minus 1 minus 2, and 2n minus 1 minus 3, and it goes on and on. So now let's go over our denominator. So we have 2n plus 1 and 2n plus 1 minus 1, 2n plus 1 minus 2, 2n plus 1 minus 3, and it goes on and on. Now let's look at it in detail. So this is equal to, we get 2n minus 1. From here we have 2n minus 2. And then here we get a 2n minus 3. And it goes on and on. Now in our denominator, we have 2n plus 1. 2n, this will cancel out. Now we have 2n, that will be minus 1, and 2n minus 2, and we see that the pattern repeats again. So now let's interpret this problem. Let's try to eliminate whatever we can, and we see that our pattern down here starts on this third factor in our denominator. So therefore this will cancel out with that, this with that, and then the entire pattern will go away. So this will leave us with no factors in our numerator, therefore we have a 1 automatically. And then in our denominator, I'm just gonna write this term first, just to be technically correct. So 2n plus 1, that's our final answer.